The theorem of Pythagoras, investigating the sides of right-angled triangles. This is Hypo. Hypo is very lazy, so we will have our hands full to motivate this guy. Let's investigate the sides of a right-angled triangle. I'm warming up. I will need a lot of energy for this. Key questions. What is a theorem? What is a right-angled triangle and a hypotenuse? What is the relationship between the shorter sides and the hypotenuse in a right-angled triangle? What is a theorem? A theorem is a rule or statement that has been proved through reasoning. In other words, it's not just something that we believe or something that looks like it. We need to test and then prove it through reasoning. So Pythagoras' theorem is a rule that applies to only right-angled triangles? Yes, Hypo, that is exactly that. So who is this guy, Pythagoras? Now this has been done by an artist, the school of Athens in 1510 to 1511. All men by nature desire knowledge. Plato, Aristotle, Socrates, Pythagoras, Euclid. They were all Greek philosophers. Pythagoras was an influential mathematician. Like many Greek mathematicians of 2,500 years ago, he was also a philosopher and a scientist. He formulated the best-known theorem, today known as the theorem of Pythagoras. However, the theorem had already been in use 1,000 years earlier by the Chinese and the Babylonians. What is a theorem again? A theorem is a rule or a statement that has been proved through reasoning. What is a right-angled triangle? What is a hypotenuse? Here is our triangle. It has a 90-degree angle, thus right-angled. We label the vertices with capital letters. This is triangle ABC. We label the sides with small letters. The side opposite angle C has got a small c. The side opposite angle B is a small b, and the side opposite angle A is a small a. The hypotenuse is the special name for the side opposite the right angle. And Hypo the dragon, that is his task today. He must always find the hypotenuse. We must keep him busy. This is triangle JKL. So side small j is opposite angle J. Small l is opposite angle L, and small k is opposite angle K. This time the hypotenuse, very good Hypo, is small k. What is the relationship between the shorter sides and the hypotenuse in a right-angled triangle? We draw squares on each side of the triangles below and record the areas in the table. In triangle 1, the short sides are 3 units and 4 units, and the hypotenuse is 5 units. If we draw a square on the short side, we form 9 squares. In triangle 1, let's draw a square on the side of 3 units. That is then 9 squares. On the side of 4 units, we form a square with 16 little squares. And the hypotenuse, 25 squares. So the small square is 9 square units, the middle square is 16 square units, and the large square 25 square units. Let's test a bigger triangle. It's also a right-angled triangle. 5 square is 25, 12 square is 144, and 13 square is 169. In our table it looks like this. 7 square, 24 square, and 25 square. 7 square is 49, 576, and 625. The hypotenuse is the longer side of a right-angled triangle. What do we notice? There's no relationship between just the sides, 3, 4, and 5, or 5, 12, and 13, but there is a relationship between the squares. Look, if we add the 2 small squares, we get the large square. 9 plus 16 is 25, 25 plus 144 is 169, and 49 plus 576 is 625. There is our relationship. The theorem of Pythagoras says, in a right-angled triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. You must be able to say this in words, using a diagram and a formula. So in a right angled triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. The square on the hypotenuse is equal to the sum of the other two squares. In short, a square is b squared plus c squared. Note, it's not a is not equal to b plus c. It's the squares that are equal. And this is the theorem of Pythagoras. In this lesson we learned what a theorem is, what a right angled triangle and hypotenuse are, and what the relationship between the shorter sides and the hypotenuse in a right triangle is.